this is what we are going to teach today. We have a flat roof, and somehow it's flat, but as you can see, we have a slope. We have slight slope here, so that water can go in this direction, and then it can be collected by this vertical pipe, and it goes all the way down to the basement. Okay. This is what we're going to design today. We're going to design this in roofs. Yeah, so eventually in some of the roofs, we will need this element, and then immediately we have to connect this to a vertical pipe going down. It's quite easy. I mean, it doesn't affect the design. We only need to make sure that the dimension of this pipe is the right dimension. If we open this Revit file, I'm going to delete everything that we did before. Okay, in this building, we have designed the water supply, we have designed the drainage. Here we have a pipe or a stack coming down from the toilets, and we have another one coming down from the lavatories or the sinks. Remember that we have to extend this pipe beyond the roof level, so this is the vent for this stack coming from the lavatories, and then we have this vent for this stack coming from the toilets. Okay, so this is what we have already done. Now we need the third system, the third drainage system. We don't have to connect these two systems. Okay, so we need this horizontal pipe should be connected to the black water sewer system of the city, and if you want to do something with this water, with the water coming from the lavatories or the washing machines, this can be considered as gray water, and you can recycle or you can reuse this gray water. This water coming from the toilet, we need to collect this water, and it ends up in a water treatment plant before being released to the river or the sea. Okay, but with this gray water, we can do something different. And with the rainwater, we can do something different. Okay, so we are going to use 3 different horizontal pipes, and they are not connected to each other. Eventually, we can connect the gray water and the rainwater. It would make sense, but we can't connect the gray and the rainwater to the water that comes from the toilet. Okay. This is what we are going to do today. We're going to create the third horizontal sanitary system that has to collect water from the flat roof. If we have a building like this, the first thing we need to understand is the area of the building, the area of the flat roof. Okay, so we have this building. I have taken measurements. So this is 140 by 70. Kind of. Okay, so this is the total area of the building. So the first thing we have to decide is how many vertical pipes we have to collect water from the rain. If we have a building 70 by 140, what is the 70 times 140? It's 9,800 square feet. So it's almost 10,000 square feet. We have to go to the lesson. If you go to this lesson on drainage, at the end, we have a table. We have this table. Okay, so if we want to collect the storm water, what is the size of each downspout? So this is based on the number of downspouts that we have in the area. What is the rule of thumb? I don't know. When I was a student, they told me that we should have like a downspout, a vertical one, each 1,000 square feet. Okay, so we divide our roof into 1,000 square feet, different sectors, and then we have a downspout. If we do that in big buildings like this one, okay, we have a 10,000 square feet roof, and we would need like 10 downspouts. I think it's too much, okay? So what can we do? So let's take a look at this table and let's try to understand what this table means. So this is the size of the drain. This is the size of the vertical pipe. Okay, it can be 2 inches, 3 inches, 4, 5, 6, 8. I think 4, it's fine because the minimum drainage or the minimum drain pipe that comes from the toilets is 4. Okay, so 4 is fine. So let's make this decision. The maximum size of the water downspout is 4 inches. Then here we have the footage or the area that we can cover with one downspout. Okay. If the rainfall is 1 inch per hour, this is a dry country, it doesn't rain. So we can cover up to 18,000 square feet. If we have a 10,000 square feet here, in a place in which it doesn't rain, having only one vertical downspout would be enough. I wouldn't do that. What is the rainfall in New Hampshire? So there's a map here. Remember this map? And here we are in New Hampshire. We are 4.8, 5.4. Okay, to be on the safe side, I would take 6. Okay, it's more than 5. So according to this is 6. The rainfall that we have to use in this table. Okay, so we can put this down. 6. So if we are in this rainfall with 6, if we are in this size 4, so we need we can have up to 3,000 square feet with one downspout. So if there are 10,000, we would need 4. Okay, to be on the safe side, I would decided that we need 4 vertical downspouts to collect the rainwater. So this is what we are going to do. So we need 4, and then we need to divide this roof in 4 different sectors, and we have to keep in mind the shafts. Okay, because you know that the shaft is something that goes from the roof up to the basement, and every single vertical pipe that we have, we need to go through these shafts. Okay, so it doesn't make any sense opening another shaft if we have already 1, 2, 3, 4, 5, 6. Okay, we have 6 shafts. It doesn't make any sense to open another one for the downspout. Okay, and now we have to divide this into 4 different sections. I'm going to take a picture of this. So if we are working with this building, here we have the shafts. This is the first one. This is the second one. The length is 140 and the width is 70. If we divide this in 4 sectors, I'm going to divide this in 4 sectors, and I'm going to one, 2, 3, 4, right. Okay, so the first thing is that all the sectors should be the same size, kind of. Okay, so if we are dividing this, and each sector is less than 3,000, because according to this table, the area, it has to be less than 3,000. Okay, so if we divide this into 4 different sectors, if the total length is 140, we divide this by 4, 140 divided by 4. So each sector is 35 times 17. Yeah, so the total area of a sector is 2,400. So it's less than 3,000. That's fine. So if we divide this into 4 different sectors, we know like some transparency. Okay. So now we have to work with the shafts. Well, we have a shaft here, another there, and the last one is here. So we could use one of those shafts for each sector. Okay, so we can place the first downspout here, the second there, the third there, and the fourth here. We can do that. Okay. So let's do it. I'm not using this one because this is crowded, because I remember that here we had all the supply and the supply air ducts, and probably there is not enough space here. This is up to you. Okay, so I would use this and this because those are big enough, and we only have the water supply pipes here, so we have enough space for the, and I think here we have enough space too. And then I would use this one and that one. Okay, so let's do it. If we are on the Revit file now, I'm going to place a vertical pipe here, so I can go to systems. Well, I'll go to the east elevation. Okay, and on the east elevation, this is the first shaft. So I'm going to go to systems, pipe. I'm going to use a 4-inch pipe, okay, because this is what I have decided. And it has to go from this point, well, here. And I want to extend this underneath the level 0. Okay, so this has to be underground. So you have to go all the way from the roof, all the way up to the, all the way down, sorry, to the, yeah, underneath the level -15, the basement slab. Where is it? Okay, so make sure that in the plan so this is the first one. The second one, I can copy this. It has to be here. The third one can be here. And the last one can be here. Okay. So now there are 4. 1, 2, 3, and 4. And they are all from the roof up to the basement. Now somehow we have to connect all these. Okay, so we have to connect all the vertical pipes with a horizontal pipe, and we can do it here. Okay, so let's go pipe. go this direction. And now we have this, then we go this way. Finally, we have to connect this one here. And we exit the building. And remember that if we draw a pipe here, no, I have to draw a pipe on level on that. Right. We have to help this, so it has to be a 45-degree angle, but I don't think it goes well. Yeah. I have to extend this here so that I can have this always this 45-degree angle. Remember that. Okay. And now I can do the same. Remember that we need this 45 angle, and then we can go back to this intersection. And from this one, we don't need anything. So now from this point, we can connect this here. And we can connect this here. Okay, I can click this. And if you have this connection, if you click here, this negative or minus sign, then you turn this into an envelope. Okay, so this is the layout now. This is the first downspout. Then we go this way, we connect this, try to connect this always in a 45-degree angle, like this. And then this is the final branch. And we exit the building. Yes.
Can you just zoom out? I think about this one.
I mean, you can use this layout or any other layout. I don't mind. You don't see this. It's underground. Okay. So the only thing is that if we agree that this is the, and we need to understand the building now, and we need to understand how the city system works. If we have this connection in the building for the rainwater, then we have to connect this here. But if the building has the connection here in this point, then we have to go in a different direction. Okay. So if we want to design that, we need to know our site. We need to know where the city system is. And then once we know where the city system is, then we can plan this layout. Okay. But it's something that it doesn't matter because it's underground. So it's not like the air ducts. The air ducts, they can be either exposed or through the false ceiling. So we have to be careful with that because they are within the building. But this is out of the building, it's underground. So the layout doesn't matter. The only thing that matters is that connections should be 45 degrees. Don't make 90 degrees connection because 45-degree connections are better. And the important thing is that we have something for the black water that comes from the toilets. We have something for the gray water that comes from it can be from sinks or washing machines, dishwashers. And then we have something different for the rainwater. We could eventually connect the gray and the rainwater. That get used to separating or not connecting the black water that comes from the toilet with the other ones. Okay? Because the water that comes from the rain can be easily purified or treated, so that we can even drink that water. Okay, we don't do that when we are in a city. We don't drink the water directly from the rain. Well, we do drink the water from the rain and from the rivers, but we have treatment plants, and then we have this water so that we can drink it. But we don't drink the water that comes from our building, from our roof. But we can use this water to water the plants. Okay, so we can do that. And sometimes we use this water to supply water to the toilet. And that's a very efficient way to save water, because the water from the toilet, we don't drink that water. And it doesn't have to be perfect. Okay, so we can use water that comes, either gray water or rainwater, to supply water to the toilets. And then we get rid definitely of this water. Okay, but those are water strategies. I'm not teaching that in this country because it's not rained a lot, so nobody cares about water here. But in other countries, or even in California or in other places where it doesn't rain, probably this would be a great concern, how to reuse the rainwater, or how to reuse the gray water. Okay, so that's it. It's quite easy. You only have to make sure that we have 4 vertical downspouts from the roof. They are within the shafts, and then they are underground. Okay, so they should be below the basement level. So we have an underground the sanitary system here. And well, here you see that the height of this horizontal pipe that comes from the toilet, this one that comes from the rain, is different. It makes sense. This building, it's not complicated, it's very simple, but sometimes we have to lay out from the toilets, and the layout from the horizontal pipe from the toilet and the horizontal pipe from the rain, they intersect each other. So that's why working with 2 different levels might work, so that we don't have this intersection. Okay, so that's it. What's next? There's another drainage that we have to work with in these systems, in buildings. So around the building, especially when we have a basement, we have to dig a trench like this. And as you can see, those guys are working on waterproofing the basement wall. If we have a basement, we have to protect this wall against the rain. So what do? We dig a trench, we apply waterproof materials on the wall, and then we fill this with aggregates. We fill this trench with, it's not sand, it's gravel, aggregates, small stones. And why would we do that? Because we need to collect the water. Okay, so this is outside, it rains. So all the water that filters, we have to collect this water before it affects the basement wall. So that's why we have to place a drainage here at this level, and the water will filter, and then it will be collected by this drainage here before entering the. So we need this. We need the pipe, a drainage pipe all around the building at this level, at the foundation level. If we have a basement, this is mandatory. If we don't have a basement, I would recommend you do that. But it's not as it's not mandatory that I would do that. Okay, so that's this is what I mean. We are working here with the basement wall, then we will go up. This will be buried, but as you can see, there is a pipe here, and this pipe Well, you see that here we have collectors. Okay, so this is the ground level. So we can collect this water, and eventually we have to connect this to the sewer system, to the city sewer system. And we can see this here. Okay, we have a basement. Here we will place the drain, the pipe, and then we will cast, or we will bury this pipe using these aggregates. But around the building, as you can see, there is always a pipe collecting water, the rainwater that filters to the soil. How can we do that in Revit? Well, we can, at the same level we have here, we can place another pipe. I'm going to do this, draw pipe, something like that. Then I'm going to delete this elbow, and I'm going to move it this way. Okay, so this pipe has to be at the same level. It has to be at this level, okay? And this connection, again, should be something at 45 degrees. Okay, I have created this pipe around the building, and then I have to extend this pipe here, then go up. And we need a slope. Okay, so don't forget, it doesn't have to be horizontal. We need a slope, 1%, 2%. But eventually, we have to connect the water that is filtered to the soil. And then this is the water that comes from the platform. Once we are out of the building, we always have a connection. And this is what we call manhole or drainage. Okay, this is a manhole. And why do we have this name? Because a man goes down and it's a hole. Okay, so you have seen this on the street. You have seen that. We have this for electricity. We have this for the sewer system. So when there's an issue, people go downstairs and fix the issue. It's disgusting, but someone has to do it. Okay, so at the before connecting this to the city system, we have a manhole like that. Okay, so here in this picture we can see. Okay, so in this picture we can see how we have the horizontal pipe here, and this is the ground level. Okay, so if we, before connecting this to the city system, if there's an issue, we can remove this cap, and then we can go down and we can see what's going on there. Okay, but usually when we connect something that comes from the building to the city system, before doing that, we always need this manhole. And I'm sure you could find nice Revit families with manholes like this. We're not going to do it because, but it has to be there. Okay. So here, before connecting this to the city system will go to the street. We need a manhole, and then we just we can connect to the building and the city. And you can see these caps If you look at it, if you walk down the city, you will find these caps anywhere. This is a New York City seaward. It sounds good. There should be copper trials and that stuff. Okay, so we are done with this building. Now you have to complete everything